So, hello everybody again. This time we're doing about lesson 5.5, magnets and magnetic materials. Let's begin. We are going to find out the difference between a magnet and a magnetic material. Make predictions about which materials are magnetic and which are not. Plan a fair test to classify materials as magnetic or non-magnetic. Describe how accurate our predictions were. Record results in a table. Describe patterns in results and point out results that do not fit the pattern. Make a conclusion from results. So, the two key words here are alloy and magnetic materials. Do you know what they mean? Let's find out. Getting started. What types of magnets are in the pictures? What do the M and S on the magnets show? Complete two sentences about what is shown in the pictures. When two wet poles come close to each other, the magnets each other. When two unwet poles come close to each other, the magnets each other. Which of the following materials is magnetic? Wood, iron, glass, plastic, or copper? What are magnetic materials? Magnetic materials are materials that are attracted to a magnet. Fridge magnets stick to a fridge because the fridge is made from a magnetic material. You already know that some metal objects are attracted to a magnet, but non-metals, like plastic and wood, are not attracted to a magnet. Some metals are precious, such as silver, gold, and platinum. None of these metals, however, is magnetic. Some of the metals that we use in everyday life are iron, steel, aluminum, copper, and chromium. Other things are made from a mixture of metals. A mixture of metals is called an alloy. For example, steel is an alloy made mainly from iron. It is much stronger than iron. We use steel to make machines, steel pipes, and bridges. Chromium is mixed with steel to make an alloy called stainless steel. Stainless steel does not rust. It is used in many objects such as knives, sinks, and medical instruments. Brass is an alloy of copper and zinc. We use brass to make door handles and ornaments. If you hold a magnet next to an object and you can feel the pulling force of the magnet, the object is attracted to the magnet. This means the object is made of magnetic material. You are going to test some metals and alloys to see if they are magnetic or not. Remember that if the object is made from an alloy, you will be testing more than one metal at the same time. Think like a scientist. Test metals to classify metals and alloys as magnetic or non-magnetic. You will need a magnet, a selection of things made from different metals and alloys, such as steel wool, a copper solar, copper wires, a brass handle or brass candlestick, steel pins, steel screws, stainless steel cutlery, steel paper clips with no plastic covering, an iron bolt or nail, copper and nickel coins, aluminum foil, a cast iron cooking pot. With the objects you have chosen, and identify the metal or alloy that each object is made from. Copy the table and fill in the first two columns. Predict which objects will be magnetic. Fill in column 3 of your table. Find a fair test to test your prediction. Check the final column if the object is magnetic. Questions. How well did your results match your predictions? Describe a pattern in your results. Was there a metal or alloy that did not fit the pattern which you were surprised about? Write a conclusion about which metals are magnetic and which are non-magnetic. List 2 ways that your test was a fair test. Which types of scientific inquiry did you practice in this activity? Choose 2 objects that you have found to be made of magnetic material. Hold them close together. Are they attracted to one another? How am I doing? Am I getting better at fair testing, describing a pattern in results, and writing a conclusion based on my science knowledge? Rate yourself with ticks. 1 tick, 2 ticks, or 3 ticks. What is the difference between a magnet and a magnetic material? A magnet is a material that has an area around it where magnetic force is active. We can't see this area. In this area, magnet can attract or repel other magnets, and it can attract a magnetic material. A magnetic material does not have an area around it where magnetic force is active like a magnet does. So a magnetic material cannot attract another magnetic material, as you discovered in question 5 above, which is this question. Wait a minute. It's question 6. Hey, it's question 6. A magnetic material can only be attracted to a magnet when it is in the magnet's area of magnetic force. Industry can use the fact that a magnet attracts magnetic materials. This photograph shows a very strong magnet moving across cars on a scrap heap. The magnet attracts the steel parts of the cars and leaves behind the plastic and glass. Activity. Magnets and magnetic materials. Name 2 magnetic materials. How can you test they are magnetic? Name 2 non-magnetic materials. How can you test they are non-magnetic? Are the 2 non-magnetic metals you chose attracted to each other? Explain why or why not. Name a non-magnetic alloy. Do you have a magnet at home, such as a fridge magnet? Use your magnet to carry out these tests. Find at least 3 examples of objects you use at home that are made of metals. Which metals are they made from? Use your magnet to test whether these objects are magnetic or not. Record your information in a table. Suggest how magnets can be used for sorting used steel cans and aluminum cans so that they can be recycled separately. How am I doing? Do I understand the difference between a magnet and a magnetic material? Choose from one of these faces: happy, normal, or sad. How can you use the knowledge you have gained from this topic? Look what I can do. I can understand the difference between a magnet and a magnetic material. I can make predictions about which materials are magnetic and which are not. I can plan and carry out a fair test. I can describe how accurate my predictions were. I can classify objects as magnetic or non-magnetic through testing. I can record results in a table. I can describe patterns in results and see that sometimes a result does not fit a pattern. I can make a conclusion from results. So that's the end of lesson 5.5. See you next time!